You know that feeling when you're absolutely sure you understand how something works, and then nature just decides to throw all your assumptions out the window? That's exactly what's happening right now with 3I/ATLAS, the interstellar comet that's currently tearing through our solar system like it owns the place. And folks, this thing just activated something that has scientists scratching their heads and rewriting textbooks. Welcome back to the channel and buckle up, because what we're about to discuss is changing everything we thought we knew about comets. Let me paint you a picture. It's July 1st, 2025, and astronomers at the Atlas Survey Station in Chile are doing their regular sky scan when they spot something unusual. At first, it's just a faint dot, barely distinguishable from the millions of other dots in space. But when they calculate its trajectory, alarm bells start going off. This thing isn't from our solar system. It's traveling at 58 kilometers per second on a hyperbolic orbit, which is science speak for this bad boy is never coming back. This is 3I/ATLAS, the third confirmed interstellar visitor we've ever detected, and it's about to teach us some seriously humbling lessons about how much we don't know. Now, here's where things get wild. When this comet was first discovered back in July, it was behaving pretty normally. Well, as normal as a visitor from another star system can behave. Scientists calculated its brightness, predicted how it would evolve as it got closer to the sun, and basically thought they had this thing figured out. Then September rolled around, and 3I/ATLAS decided to throw the biggest curveball in modern astronomy. Around early to mid-September, right when the comet crossed the 2 astronomical unit mark from the sun, something activated. And I don't mean activated like your phone screen lights up. I mean this thing suddenly started glowing way brighter than it had any right to. Let me give you some context here. An astronomical unit is the distance from Earth to the sun, about 93 million miles. 2 astronomical units is twice that distance. At that range, comets are supposed to be relatively chill. The sun's heat hasn't really kicked in yet. Ice sublimation should be minimal, and brightness increases should be gradual and predictable. But 3I/ATLAS looked at our predictions and basically said, yeah, I'm going to do my own thing. The brightness spike was so dramatic that astronomers thought their instruments were malfunctioning. Spoiler alert, the instruments were fine. The comet was just being absolutely bonkers. On October 2nd, something incredible happened that I need to tell you about. NASA's Perseverance rover on Mars, which normally spends its days drilling rocks and looking for ancient microbial life, decided to do some nighttime stargazing. During a 9-minute imaging session with stacked exposures, Perseverance captured something extraordinary. There, slicing through the vertical star trails created by Mars's rotation, was a narrow diagonal streak. This wasn't a random cosmic ray hit. This wasn't a Martian satellite. The timing, the angle, the velocity, everything matched perfectly with where 3I/ATLAS should have been in the sky. A rover on another planet just photographed an interstellar comet streaking past. Let that sink in for a second. We're using robots on Mars to watch visitors from other star systems. How absolutely insane is that? But here's what really gets me excited, and this is where the activated something part becomes crucial. Scientists have been studying 3I/ATLAS with every telescope they can point at it, including the James Webb Space Telescope. And they've discovered that this comet is producing water at an absolutely ridiculous rate. We're talking 88 pounds of water per second. That's like having a fire hose running at full blast, except instead of watering your lawn, it's spraying water into the vacuum of space. NASA scientists literally described it as a cosmic fire hydrant. And honestly, I can't think of a better description. Now you might be thinking, okay, comets produce water when they get close to the sun. What's the big deal? Here's the big deal. 3I/ATLAS is producing this massive amount of water at a distance where it absolutely should not be doing that. Normal comets don't start their major water production until they get much closer to the sun. The fact that this thing activated its water production so early and so dramatically tells us something fundamental about its composition and structure. This isn't a normal comet. This is a comet from a completely different stellar neighborhood that formed under completely different conditions. And it gets even weirder. When scientists analyzed the composition of 3I/ATLAS using spectroscopy, which is basically using light to figure out what chemicals are present, they found something that made them do a double take. This comet has an 8-to-1 ratio of carbon dioxide to water. Let me repeat that because it's absolutely wild. 8 parts carbon dioxide to 1 part water. Most comets in our solar system are the complete opposite. They're water-rich with relatively little CO2. It's like ordering a soda and getting a cup that's 80% carbonation and only 20% actual liquid. This composition is so unusual that it's forcing scientists to completely reconsider how comets form in different star systems. Here's my favorite theory about what's happening, and it involves that crazy CO2 content. Scientists think that the carbon dioxide in 3I/ATLAS is sublimating, turning from solid directly into gas much more easily than the water ice. And when that CO2 sublimates, it's so energetic that it's literally dragging water molecules along for the ride. It's like when you shake up a soda bottle and then open it. Everything comes spraying out in an explosive burst. The CO2 is the fizz, and the water is just along for this wild, explosive ride through space. This mechanism could explain why the comet activated so early and so dramatically. It's not following the rules we're used to because it's playing by a completely different set of physics. Let's talk about timing because this is crucial. Right now, as we speak, 3I/ATLAS is approaching its perihelion, which is the closest point to the Sun in its orbit. This is scheduled to happen between October 29th and 31st, and the comet will be at about 0.36 astronomical units from the Sun. That's closer than Mercury's orbit. This is when things are going to get really intense. All that ice and CO2 we've been talking about, it's going to be sublimating like crazy under the intense solar radiation. Scientists are predicting that if 3I/ATLAS is going to do anything truly spectacular, whether that's a massive brightness surge, structural fragmentation, or some other surprise, it's going to happen during this perihelion passage. But here's the catch, and this is where the story gets frustratingly beautiful. On October 21st, we hit what's called superior conjunction. This is when the Sun positions itself directly between 3I/ATLAS and Earth. From our perspective, the comet essentially vanishes behind the solar glare. It's like trying to spot a firefly next to a spotlight. Impossible. Ground-based telescopes on Earth become completely useless during this period. We're basically going blind right when things are getting interesting. This is where Mars becomes the hero of our story. Remember how I mentioned that 3I/ATLAS passed close to Mars on October 3rd? It came within about 28 million kilometers of the red planet, which in space terms is basically a cosmic near miss. The beautiful irony here is that while Earth's telescopes are blinded by the Sun, Mars has a front row seat, and we've got an entire fleet of spacecraft orbiting Mars ready to observe. Europe's Mars Express and the ExoMars Trace Gas Orbiter are positioned perfectly. NASA's Mars Reconnaissance Orbiter, with its incredible high-resolution camera, is ready to capture detailed images. The MAVEN atmospheric probe is standing by. Even China's Tianwen-1 and the UAE's HOPE mission might contribute data if they can swivel their instruments fast enough. This is modern astronomy at its finest. We've literally positioned backup cameras on another planet so that when one viewpoint goes dark, we can switch perspectives and keep watching. It's like having security cameras covering every angle of your house. When the front door camera gets blocked, the side cameras pick up the action. Except instead of catching package thieves, we're catching interstellar comets doing physics we don't fully understand yet. Now let me address the elephant in the room. Shortly after 3I/ATLAS was discovered, there was some speculation, particularly from a certain astrophysicist, who shall remain named Avi Loeb, that this might be some kind of alien technology because of its anomalous characteristics. This happened back in July, and the scientific community collectively rolled their eyes so hard, I'm surprised it didn't affect Earth's rotation. Within days, multiple teams using 4 different major telescopes, including the James Webb Space Telescope, all confirmed the same thing. This is definitely a comet. It has all the classic signatures of cometary activity. It's outgassing, it has a coma, it's behaving like a comet. It just happens to have a weird composition because it formed around a different star. Look, I understand the appeal of the alien hypothesis. It's exciting, it's mysterious, it gets clicks, but the real story here is actually way more interesting than aliens. What we're witnessing is proof that planetary systems around other stars can be fundamentally, dramatically different from ours. That 8:1 CO2 to water ratio isn't evidence of alien technology. It's evidence that the universe is far more diverse and creative than we gave it credit for. Every star system might have its own unique chemical signature, its own special recipe for making planets and comets. 3I/ATLAS is like receiving a cookbook from a restaurant in another galaxy, and it turns out they use completely different ingredients than we do. Let's talk about age for a moment, because this adds another mind-blowing layer to the story. Based on its trajectory and composition, scientists estimate that 3I/ATLAS is somewhere between 7.6 and 14 billion years old. Our entire solar system is only 4.6 billion years old. This comet might have been wandering through the Milky Way since before Earth even existed. It could have witnessed the birth and death of entire generations of stars. It might have passed by planets we can only dream about. This thing is older than our cosmic neighborhood, and it's carrying secrets from a time when the universe looked completely different. Scientists think 3I/ATLAS probably comes from what's called the thick disk population of the Milky Way, which is basically the old-timers club of our galaxy. These are objects that formed early in the galaxy's history, and they've been wandering around ever since. In just the last 10 million years, this comet has passed within about 3 light years of 25 different known stars. Imagine the cosmic tour this thing has been on. It's like the universe's oldest tourist, and we just happened to catch it during a brief stopover at our solar system. This is modern astronomy at its finest. We've literally positioned backup cameras on another planet so that when one viewpoint goes dark, we can switch perspectives and keep watching. It's like having security cameras covering every angle of your house. When the front door camera gets blocked, the side cameras pick up the action. Except instead of catching package thieves, we're catching interstellar comets doing physics we don't fully understand yet. Now let me address the elephant in the room. Shortly after 3I/Atlas was discovered, there was some speculation, particularly from a certain astrophysicist who shall remain named Avi Loeb, that this might be some kind of alien technology because of its anomalous characteristics. This happened back in July, and the scientific community collectively rolled their eyes so hard, I'm surprised it didn't affect Earth's rotation. Within days, multiple teams using 4 different major telescopes, including the James Webb Space Telescope, all confirmed the same thing. This is definitely a comet. It has all the classic signatures of cometary activity. It's outgassing, it has a coma, it's behaving like a comet. It just happens to have a weird composition because it formed around a different star. Look, I understand the appeal of the alien hypothesis. It's exciting, it's mysterious, it gets clicks. But the real story here is actually way more interesting than aliens. What we're witnessing is proof that planetary systems around other stars can be fundamentally, dramatically different from ours. That 8:1 CO2 to water ratio isn't evidence of alien technology. It's evidence that the universe is far more diverse and creative than we gave it credit for. Every star system might have its own unique chemical signature, its own special recipe for making planets and comets. 3I/Atlas is like receiving a cookbook from a restaurant in another galaxy, and it turns out they use completely different ingredients than we do. Let's talk about age for a moment, because this adds another mind-blowing layer to the story. Based on its trajectory and composition, scientists estimate that 3I/Atlas is somewhere between 7.6 and 14 billion years old. Our entire solar system is only 4.6 billion years old. This comet might have been wandering through the Milky Way since before Earth even existed. It could have witnessed the birth and death of entire generations of stars. It might have passed by planets we can only dream about. This thing is older than our cosmic neighborhood, and it's carrying secrets from a time when the universe looked completely different. Scientists think 3I/Atlas probably comes from what's called the thick disk population of the Milky Way, which is basically the old-timers club of our galaxy. These are objects that formed early in the galaxy's history, and they've been wandering around ever since. In just the last 10 million years, this comet has passed within about 3 light years of 25 different known stars. Imagine the cosmic tour this thing has been on. It's like the universe's oldest tourist, and we just happened to catch it during a brief stopover at our solar system. The spectroscopic data that's coming in is absolutely fascinating. When scientists point spectrographs at 3I/Atlas, they're not just detecting water and CO2. They're also finding carbon monoxide, cyanide gas, and even atomic nickel vapor. This is a chemistry set from another star system, and every element we detect tells us something about the conditions where this comet formed. Maybe the star it originally orbited was a different type than our Sun. Maybe the protoplanetary disk it condensed from had a completely different elemental composition. Whatever the story is, 3I/Atlas is rewriting it in real time across our telescopes. Here's something that really drives home how special this moment is. 3I/Atlas is incredibly faint, with an apparent magnitude around 12 to 14. You absolutely cannot see it with the naked eye. You need at least a decent backyard telescope just to spot it as a fuzzy dot. And yet, with our modern instruments, we can analyze its chemical composition in exquisite detail, track its trajectory with incredible precision, and even photograph it from Mars. We're living in an era where we can do detailed chemistry on objects from other star systems while they're moving at 130,000 miles per hour. That's not just cool, that's historically unprecedented. The brightness anomaly that started in September is still one of the biggest mysteries. Scientists have proposed several explanations. Maybe the comet had a subsurface reservoir of volatile materials that suddenly broke through to the surface, like a pressurized pocket of gas finding a crack. Maybe the rotation of the comet exposed a particularly ice-rich area to sunlight for the first time. Maybe that unusual CO2 content created a cascade effect where one type of sublimation triggered another. Or maybe, and this is the exciting possibility, we're witnessing a type of cometary behavior that simply doesn't happen with solar system comets because they don't have this bizarre composition. This is what makes 3I/Atlas such a game changer. Before interstellar objects started showing up, we could only study comets from our own solar system. Sure, we could detect exoplanets around other stars, but those are massive objects that we observe indirectly through their gravitational effects or the dimming of starlight. Comets are much smaller, and until recently, we had no way to study them from other star systems. Now, with objects like 3I/Atlas passing through, we're getting direct samples of material from alien solar systems delivered right to our doorstep. It's like the universe is running a cosmic delivery service, and every package teaches us something new. One of the things that really fascinates me about this whole situation is the international collaboration aspect. You've got telescopes in Chile discovering the comet. You've got the James Webb Space Telescope, an international collaboration between NASA, ESA, and the Canadian Space Agency analyzing its composition. You've got European spacecraft at Mars ready to observe during perihelion. You've got American rovers photographing it from the Martian surface. You've got Chinese and Emirati missions potentially contributing data. This is humanity at its best, all working together to understand something that none of us has ever seen before. After perihelion on October 29th, 3I/Atlas will begin its long journey back out of the solar system. The comet will gradually fade as it gets farther from the sun, and by late November or early December, it'll probably be too faint for most telescopes to track effectively. Then it'll be gone, continuing its billion-year journey through the galaxy, possibly never to encounter another star system for millions of years. Or maybe it'll swing by some alien civilization in a few thousand years and give their astronomers the same thrill we're experiencing right now. Imagine that for a second. Some alien astronomer billions of years from now pointing their telescope at 3I/Atlas and wondering where it came from, not knowing it once passed through a solar system with a curious species that built robots on multiple planets just to watch it go by. But here's the beautiful part. Even after 3I/Atlas disappears from view, the data we collect will keep scientists busy for years. Every spectroscopic measurement, every brightness reading, every photograph from Mars, every mathematical model, all of it will be analyzed and reanalyzed. Graduate students will write dissertations about this comet. Papers will be published comparing it to other comets, both interstellar and local, and slowly, piece by piece, we'll build a more complete picture of how diverse planetary systems can be. The European Space Agency's JUICE spacecraft is also getting ready to conduct some extended observations of 3I/Atlas from deeper in the inner solar system. The geometric positioning is excellent, but there are operational constraints involving communication and line-of-sight geometry that means some of this data might not reach public archives until early 2026. Science is sometimes a waiting game. We play the long game because that's what methodological rigor demands. Patience isn't just a virtue in astronomy, it's a requirement. I want to zoom out for a second and talk about what this all means in the bigger picture. In less than a decade, we've now encountered 3 confirmed interstellar visitors: Oumuamua in 2017, Borisov in 2019, and now 3I/Atlas in 2025. Each one has violated different expectations and taught us different lessons. Oumuamua had that weird acceleration and elongated shape that sparked all kinds of speculation. Borisov looked like a normal comet, but was moving on an interstellar trajectory, proving that some things from other star systems can look familiar. And now 3I/Atlas is showing us that comet composition can be radically different from what we're used to, even when the basic physics remains the same. Every single one of these visitors is expanding our understanding of what's possible in the universe. And here's the kicker. Astronomers think there could be thousands of these interstellar objects passing through the solar system at any given time. We're just now getting good enough at detecting them. The Atlas survey system that discovered 3I/Atlas was originally designed to spot asteroids that might hit Earth, a planetary defense system essentially. But it's turned out to be fantastic at finding these cosmic wanderers too. As our detection systems improve and we build more powerful automated survey telescopes, we're going to find more and more of these visitors, and each one is going to teach us something new. Within the next decade, finding interstellar objects might become routine. We might have catalogs of them, classification systems, entire research programs dedicated to studying them. Think about the implications here. Every star in our galaxy probably has comets. When planetary systems form, they create these icy leftovers that get kicked out into interstellar space by gravitational interactions with giant planets. Our galaxy is essentially swimming in these objects, wandering between the stars, carrying chemical information about their home systems. We're basically living in a universe where comets are nature's way of sharing recipes. Each one is a message in a bottle, except the bottle is made of ice and rock, and the message is written in chemical composition. It's the most beautiful form of cosmic communication imaginable. The fact that 3I/Atlas activated so dramatically and so early tells us that our models for cometary behavior are incomplete. We've been building these models based solely on solar system comets, which are all made from the same basic recipe because they all formed in the same protoplanetary disk around the same star. But now we're getting comets from completely different kitchens, and they're showing us that there are other ways to make a comet. Some are water-rich, some are CO2-rich, some probably have compositions we haven't even imagined yet. The universe is more diverse than our textbooks suggested, and 3I/Atlas is proof. Every astronomy textbook written before 2025 is now technically outdated because of this one comet. So what happens next? Well, for the next 2 weeks, Every telescope that can see 3I/Atlas will be pointed at it, gathering data like crazy. Amateur astronomers with backyard telescopes are contributing observations. Professional observatories are scheduling dedicated observation time. The Mars orbiters will be watching during perihelion when Earth's view is blocked. Scientists will be monitoring for any changes in brightness, any outbursts, any fragmentations, any surprises. This is citizen science and professional astronomy working hand in hand, and it's beautiful to watch. And then, after the comet swings around the sun and heads back out into deep space, we'll spend months and years analyzing all that data, trying to piece together exactly what we witnessed. Conference presentations will be given. Peer-reviewed papers will be published. Arguments will break out in academic journals about the best interpretation of the data. That's how science advances, through rigorous debate and careful analysis, not through quick hot takes and sensational headlines. This is science at its absolute best. We're not dealing with grand theories or philosophical speculation. We're dealing with hard data, mathematical models, spectroscopic measurements, and photographic evidence. We're watching nature do its thing and trying to understand the rules. And when nature throws us a curveball like the brightness anomaly or the bizarre CO2 ratio, we don't ignore it or explain it away. We lean into it. We ask harder questions. We build better models. We admit what we don't know and get to work figuring it out. That's how progress happens, one careful observation at a time. I started this video by talking about how 3I/Atlas activated something we don't fully understand yet. That activation, that sudden brightness surge in September, is still one of the great mysteries of this whole story. But you know what? That's exactly how I like my science. Give me mysteries. Give me anomalies. Give me things that don't fit the models, because that's where the interesting discoveries live. That's where our understanding grows. The questions we can't answer yet are far more exciting than the questions we already know the answer to. So keep your eyes on the news over the next couple of weeks. Scientists will be releasing new observations and data about 3I/Atlas as it reaches perihelion. Follow the space news websites, check the astronomical bulletins, watch for press releases from NASA and ESA. Who knows what else we'll discover? Maybe the comet will surprise us again. Maybe it'll fragment into multiple pieces under the intense solar heat. Maybe it'll have another massive outburst. Or maybe it'll teach us something completely unexpected about how comets work that we never even thought to ask. Whatever happens, it's going to be fascinating, and we get to watch it unfold in real time. Thanks for watching, and if you enjoyed diving deep into the mysteries of this interstellar visitor, smash that like button and subscribe for more content about the weird and wonderful universe we live in. Drop a comment and let me know what you think is causing that brightness anomaly. Are you Team Subsurface Volatile Reservoir or Team Bizarre CO2 Cascade Effect? Or maybe you have a completely different theory. I want to hear your thoughts. Until next time, keep looking up and remember that the universe is under no obligation to make sense to us, but it does have to follow the laws of physics, and that's where we find our answers. See you in the next video.